Everyone, you are welcome to another class with Mr. Olukorede. Today we are going to look at some past questions on WAEC and Neco. Okay, so we are going to focus only on bearings and distances. So before we commence, I want you to get your writing materials ready and get your biro, your calculator, and also don't forget to invite your friends. Okay, let them know the class is about starting. Okay, if today is your first time joining us on this platform, ensure you subscribe to this channel and don't forget to tap the like button. All right, okay, so anytime from now we're going to commence the class. So ensure you invite your friends, tell them that the class is about starting. Okay. Uh, all right, okay, so let's start with the first question we have here. Two boats A and B left port C at the same time on different routes. A traveled on a bearing of 150 and B traveled on a bearing of 150 degrees and A on the north side of B. So when A covers 8 kilometers, B had covered 10 kilometers and their distance apart is 12 kilometers. So calculate the bearing of A's route from C. So how do you answer this question? And the first thing to do is to ensure that you understand the concept of the question. Okay, so you can just sketch the diagram somewhere before you do your final drawing. Okay, so now let us look at this question. All right, okay. Now the question is talking about two boats leaving a port, and that port is port C. All right, so now let's assume we have the port here, this port C. Okay, don't forget, these are cardinal points where this is the north, this is the east, this is the south, and this is the west. All right, from north to east is 90 degrees, from east to south 90 degrees, south to west 90, and west to north is 90 degrees. So the total angle is 360 degrees. Just take note of that. All right, so the question says two boats A and B leave port C at the same time on different routes. Now, B travels on a bearing of 150. Okay, 150. Let's move this port C. Let's move it down a little bit. Okay, let's move it down. So, okay, these are port C. Now, A travels on this bearing. Okay, what is the bearing? Now we have B traveled on bearing of, okay, B traveled on bearing of 150 degrees. So we start our reading from the North Pole, 150 degrees. So you move down, okay. So now, you know, from your north to your east is 90. So you need how many angle to have to hit? I think that should be 60, right? Okay, so so that means it will tilt towards the south more than the east. So, and then you bring it down this way. So this is your point B. Okay, so the bearing is 150 degrees. Okay, so now B traveled on a bearing of 150 degrees and A of B. Now, north side of B is up here. All right, so that means A will go in this direction, so it's going to go this direction. All right, okay, but now we don't know how far A has moved, but let's read further. Now When A covered 8 kilometers, B had covered 10 kilometers. So that means B will travel longer than A. So now in our drawing, this length now must be longer than this for A. So now here is 10 kilometers. Okay, so let's try and reduce this a little bit. Okay, so this is 8 kilometers. And this point A. Do you understand that? Okay, so now A traveled towards the north of what? Of B. All right. While B traveled on a bearing of 150 degrees. All right. So now let's join the points together. Let's join these together. So we have something of this form. Okay. Okay. So now that is the point. Okay. Can you see that now? So now let's move on. And their distance apart is 12 kilometers. Now, the distance between A and B is 12 kilometers. So, we have this to be 12 kilometers. All right. So, now, the question is now asking, calculate the bearing of A's route from C. That is the bearing of this A from C. So, we want to get the angle here. The bearing of A from C. So we are taking the bearing from C. I hope you understand that. Okay, so now, how do we get this angle here? So now, what we are going to do now, let us get the angle we have here. And let's get that. So once we get this angle here, let's call it theta. So we just take that angle away from 150. So what we are going to be left with now is going to be the bearing of A from C. All right, because from here, from the North Pole down to this place is 150. Okay, so now this small angle here inside the triangle. So let's get that. We take it away from everything. So we are left with this small angle. So we can call this one alpha. So alpha plus theta, that gives us 150 degrees. Okay, so now let's get angle theta. So angle theta is the same thing as this angle C. So what formula are we going to be using? We are going to be using cosine rule. Okay. So since we have an included angle, all right. So we have C squared equals to A squared plus B squared minus 2AB cos C. So this is the formula we're going to be using. All right. So now side C has been given to be 12. We have 12 squared. Side A, this side A, okay? Side A is 10. So we have 10 squared plus side B, that's 8. So plus 8 square minus 2 times 10 times 8 times cos C. All right? So here we have 144 plus 1 equals to 100 plus 64 minus that is 16, that's 160 cos C. Okay, so now let's add this together. We have 144 equals to 164 minus 160 cos C. Okay, so now let us transpose this 164. So we have 144 minus 164 equals to negative 160 cos C. Okay, can we do the remaining one here? Okay, so here, now when you subtract, what do you have? You have 20, okay? We have 20. Here is 20 equals to negative 160. This negative 20, sorry, negative 20 cos C. All right. So here you can divide both sides by negative 160. So we have negative 20 over negative 160 equals to cos C. All right. So cos C equals to 0 cancel 0, negative cancel. That's 1 over 8. Okay. And that is the same thing as 0.125. So now to get C, now you find arc cos of this. So we have C equals to arc cos of 0.125. Okay, so C now gives you what? So you can check your 4-figure table or your calculator. So let's see, what do we have for that? So if you have the answer there, so can you drop that in the comment section? Let's see. So I want us to participate in the class, so don't let me be the only person that will be doing it. Okay, so what's going to be the arc cos inverse of cos of 0.125? So if you have the answer, you can drop that in the comment section. Okay. All right. Anyone with the answer? So if you have the answer, drop that in the comment section. Let's see. Arc cos of 0.125. Okay. Anybody? Okay, I can see King. Okay. All right. So that's 82.81. All right. Is there any other answer different from that? If you have anything different, let me see that. Okay. All right. So what I have here is 82.82 degrees. All right. So, and that is the same thing as our theta. C is theta. So now what we want now is the bearing of this A from C. So I just come from the north pole of C and I'll begin to measure it down until I get to the line that is connecting A and C. So since from here to here is 150, so let's take away this from 150. So when you take this away from 150, what do you have? So we now have bearing of A from C, that gives you 150 minus 82.82. So what do you have? You have 67.18 degrees. Okay, so when you take away this from 150, so this is what you have. So, and that is going to be the bearing of this. But don't forget, you can't leave your answer this way. You must correct it to the nearest whole number, and it must be in 3-figure for you to get the answer. So now this is going to be approximately 0.67 degrees. So to the nearest degree. So this is the bearing of A from C. That is the answer to that problem. So before I move to the next question, is there any question based on what you have done? So if you have any question, any reservation based on what you have done, please kindly drop that in the comment section. So let's look at another question. Oh, sorry. Okay, sorry. Diagram should not be in that direction. Okay. Let's see. This one should be longer. Oh, should be longer. All right. Okay. Yes. This is another question. So I want us to solve the problem together. So we are given a diagram here now. So now said in the diagram, the bearing of A from B is 320 degrees, and the bearing of B from C is 240 degrees. So we are given that AB, line AB equals to line BC. All right. So we have to calculate angle BCA. Angle BCA and the bearing of C from A. So how do we go about this? Now we have to examine the diagram very well. So let's see what the question is saying about the diagram. Now in the diagram, the bearing of this A from B, bearing of this A from B is 320 degrees. Now don't forget the definition of bearing is the angle measured clockwise from the north direction. Okay, so now let's get the bearing of A from B. So from B, so that is 320. So we have it this way, down from here to this place. So this angle here is 320 degrees. Now, does this one sound something to us? Now, when you look at this place now, this place is going to be what? That's going to give you 40. Because from North Pole back to North Pole, That is 360 degrees. So if you have covered 220, okay, so you'll be left with 40 degrees. So that means this angle here is 40 degrees. So 40 degrees. Now let's take note of that. Okay, so now the next, and the bearing of B, the bearing of this B from C is 240. So from C, the bearing of this B from C is 240. Now, can we read it now? 240. So moving this way. Now, once you move to this level here, we have covered 180. So we are moving down to what? To 240. So that means we need to move like 60. Okay, is this 60 or 50? Okay, so all right, so to give us 240. Do you understand now? So this place is going to be 60 here. All right, so and that's 180 plus 60, that gives you 240. So now the bearing here is 240 degrees. So this small angle here now is going to be 60 degrees, because from here to this place is 180. So 180 plus 60, that gives you 240 degrees. I hope you understand that. Okay, so now the question now wants us to calculate angle BCA. Angle BCA. So this is the angle we want to get now. We want to get this angle BCA. So now, don't forget that this angle here is alternate to this. This angle here is alternate to this angle. All right, so that makes this one now to be 60 degrees as well. So we have 60 degrees. So the total angle we have here now is what? That will be 100 degrees. 100 degrees. And now look at this diagram carefully. You will see that this is an isosceles triangle, because this side and this side are equal. So that means the base angle must also be equal. So now we can represent each of the angle by x because they are equal. All right. So sum of angle in a triangle is 180. So I will go ahead and write x plus 100 equals to 180 degrees. Sum of angles in a triangle. Okay, so now we have 2x plus 100 equals to 180 degrees. So we have 2x equals to 180 degrees minus 100. So we have 2x equals to 80 degrees. And x equals to 80 degrees over 2. So x is what? 40 degrees. So x is 40 degrees. And that happened to be angle ACB or angle BCA. All right? So we now say, therefore, angle BCA is 40 degrees. So that is the answer to that. Now let's move down to the second part of the question. Now the question wants us to calculate the bearing of C from A. The bearing of C from A. So from A, so you come to A now. So we want to know this. Okay, that is what we want to know. Now, let's see. We already know the value here, and we also know the value here because this is 40 degrees. So if this one is 40 degrees, it means this place too is also going to be 40 degrees. So this is going to be 40 degrees. Okay, 40 degrees. Now the angle here is what? Is 40 as well. Okay, because this and these are equal. So this is 40. So we also have x to be 40 degrees. Now to get the bearing of this C from A, and that's what the question is asking for. The bearing of C from A, from this north to this place is 180 degrees. All right. So all we just need to do is just to take away this 40 and this 40 from 180 degrees. That gives us the bearing of A C from A. So we now have bearing of C from A is 180 minus 40 plus 40. Okay, these two 40. So you take it from 180. And that's going to give you 180 minus 80. So, and the answer is going to be what? 100 degrees. So that is the bearing of C from A. Bearing of C from A. So, and that answered the question. All right. So, yes, I want to believe you guys are learning. So if you have any question based or reservation based on what we just did now, please kindly drop in the comment section. And don't forget, if you have joined this class, ensure you tap the like button. If you have not subscribed, ensure you do that. If you are new on this channel, make sure you click on the notification button. Okay, so any question based on what we just did now? Any question? Yes, I'm waiting for your response. Any question based on what we just did now? All right, so I'm not seeing any response. So so that means there's no problem. So we can proceed to the next question I have for you today. So let's proceed to the next question. Okay. Yes, this is another question. I want us to look at this question together. Okay. A cottage is on a bearing of 200 degrees and 110 degrees from A's and B's farm respectively. If A walked 5 kilometers and B 3 kilometers from the cottage to their farms. So find correct to 2SF, the distance between the two farms and the bearing of B's from A's farm. All right, so I hope we all understand this question. All right, so once I have this type of bearing question, the first thing is I'll read the question for just like 2 times and have a sketch of what the question is talking about before I start drawing. That will help me now to get a perfect drawing. Okay, so now let's look at the question now. Now, a cottage is on a bearing. Now, if you listen to the question, you examine the question, you will see that now the location of the cottage is being described here. Now, a cottage is on a bearing of 200 degrees and 110 degrees from A's and B's farm respectively. Okay, so the position of this cottage is being described in respect to A's and B's farm. So that means A's and B's farm will determine the position of the cottage. So now the first point we need to locate here is not the cottage. Okay, because what determines the position of the cottage is A and B farms. Okay, A and B farms. Okay, so now let us locate point A and point B. Don't forget now, from A, the bearing of cottage is 200. So now the first point I'm going to draw now is going to be A. So and that will determine the position of the cottage. All right, so 200. So let's have it this way. Now, this is point A. Okay, point A. So now let's draw it 200. 200 down 180 plus 20 gives us 200. So we just have a very small angle very close to the south. So and it moves down. Okay, it moves down. So it moves down. So this is the position of the cottage. Let's represent that with C. So now the bearing here is 200 degrees. All right, so now we also have B is cottage is 110 degrees from B. Okay, 110 from B. Okay, so now, so if I'm drawing 110, so I will look at this C now. 110 is going to fall in the second quadrant. Okay, first quadrant we have maximum of 90. So from 90 up also we have so second quadrant. So if I'm going to be drawing the second quadrant now, so and I want it to connect with this, so it should be around this place. Okay, so now before I start drawing, I have to look at the distance given, so I will know how far I'm going to push this point B. All right, let's see how far they traveled. Now A walked 5 kilometers, so that means A have the longer length, so we have 5 kilometers here. So now I can make this closer now. Okay. So, and I want to do 200 from here. 110, sorry, 110. So you move down 110 from B. Is 110. Okay. So we can now connect that. Okay, let's do it this way. 110 because a very small angle. So here we have angle 110 here. This is 110. 110 degrees from B. So we have a very small angle. We should have a very small angle here. Okay. So probably maybe it's supposed to tilt toward this. So that should be our sketch. So because we have a very small angle. All right. So let me draw it this way. So we have a very small angle. So tilt towards this. 110. Okay, so now this is it. So we have 110 this way. All right. So this angle here is 110 degrees. Okay, so let's join this point together. Don't forget this place is B. This is B. We have B here. This is point B. Point B. Now C is 110 degrees from B. And the C is also 200 degrees from A. And that's what the question is saying. All right. So now let's join the points together. Okay. So this is point C. We have point C, point A, and the point B. Okay. So now the question now says, find correct to two significant figure the distance between the two farms. So that is the distance between A and B. A and B. The distance here is 3 kilometers. That has been given in the question. So we want to get the distance. So now let's analyze the angles we have here. So look at here. Now we have small angle here. This place is 20. This place is 20 degrees because you know, from here down to this place is 200. So when you take 180 from 200, you have 20. So we have this one. This angle here is alternate to this. So that means this place is 20 as well. Also, now you know from the North Pole down to the South is 180. So now we have 110 to this place. So we just take 110 away from 180. So we'll be left with 70 here. Okay, so when you had 70 plus 110, everything down to this place, so you have 180. So that means this angle here will be alternate to this. So this place is 70. So the total angle we have here now will be what? 90 degrees. Okay, so that means this triangle is a right angle triangle. So what comes to mind now is, if I'm solving anything here, I must make use of either Pythagoras theorem or trigonometrical ratio. Okay, so since I want to get this one here, so I can make use of Pythagoras theorem. So now I have, this is my hypotenuse. So I have AB square will be the square of the two sides. So we have 5 square plus 3 square. All right, so that gives you 25 plus 9. So, and that gives you 34. So we now have AB is the square root of 34. And that's going to be in kilometers. Okay, so the distance here now is square root of 34. So let's see, what do we have for that? What is square root of 34? Can you tell me? Can you drop your answer in the comment section? All right, so make sure you are doing something. Square root of 34. So what do you have? What do you have? Square root of 34. Okay, can you compute that and drop your answer in the comment section? What's square root of 34? Anyone? Square root of 34. Okay, so if you have your answer, you can drop it there. So what I have here is 5.83. 5.83 kilometers. So this place is 5.83 kilometers. All right. So now we've answered the first part of the question, but the question asks us to correct to the nearest 2 SF. So our answer now is going to be what? 5.8 kilometers. So 2 SF. Okay. So the first part, we have 5.8 kilometers. So 2 SF. All right, so if you are correcting it to 2SF, just count the first significant digit here is 5, the second one is this. So you truncate the remaining ones and check if this is up to 5. If it's up to 5, you increase this by 1. So since it's not up to 5, you truncate. So and that's the answer. Okay, so now let's look at the second part. Now the bearing of B from A's farm. The bearing of B from A farm. So we want to know the bearing of this B from A. The bearing of B from A. So now, this is what we want to get. Because since we want to take the bearing from A, okay, so we start from the north pole of A, we move it down until we get to the line that is connecting the two. So here. So that is the bearing of B from A. The bearing of this B from A. All right, so we already know part of this. So let us get this angle here, and then we add it to 200. So that gives us the bearing of B from A. You get that now? You know, everything here down to this point here, this line here is 200. So we just need this small angle. Let's call it alpha. Okay, so, and then we are good to go. All right, so how do we do that? All right, so we can make use of trigonometrical ratio. So let's make use of trigonometrical ratio. Now, we want to get these opposites, these adjacents, because this is my reference angle. I want to get this. So this is going to be my adjacent, and this will be my opposite. So I'm going to be using tan. So I have tan alpha equals to opposite, that's 3 over adjacent, that's 5. Okay, so that's going to be alpha equals to arctan of 0.6. Okay, so now can you compute this and drop your answer in the comment section? So what's going to be the arctan of 0.6? So you can check that on your possible table, or you punch your calculator. So if you have the answer to that, please kindly drop that in the comment section before we continue. What is the arctan of 0.6? Arctan of 0.6. Okay. All right. I think I can see some answers. Okay. That's 30.96. Okay, 30.96, 30.9. Okay, good. All right. So yes, I can see our answers. So that's 30.96. 30.96 degrees. Okay, so now this is 30.96 degrees. So we add that to 200. So that gives us the bearing of B from A. So bearing of B from A equals to 200 plus 30.96. And that gives us 230.96 degrees. And that's approximately what? That is approximately 231 degrees. So you correct to the nearest nearest degrees. So that's 231. All right. So that is the answer to the problem. So I hope you all understand that. So any question based on the question on the board? Any observation? Please, if you have any observation, please drop that in the comment section before we move down to the next one. I'm moving to another question. Okay, so all right, there's no question, so let's move down. Let me check any question based on what we have done. All right, so now let's move down to another problem. All right. Can we look at the next question? An aeroplane flies from a point X on a bearing of north 45 degrees east to another point Y, a distance of 200 kilometers. It then changes course and flies to another point Z on a bearing of south 40 degrees east. So if X is directly west of Z, so calculate, correct to three significant figure the distance X to Z, and the distance from Y to length XZ. All right, so now let's sketch the diagram. Now let's look at it. An aeroplane flies from a point X on a bearing of this. So that means the first point I'm drawing here now is X, because the aeroplane starts flying from a point X. So, and that is going to be here. Let's see here. Okay, this is my north and this is my east. So it's moving 45. So I'm doing my rough sketch before I now start drawing. So this is 45 degrees. Okay, so to another point Y. So we have one point Y here. This is Y. Okay, a distance of 200 kilometers. Okay, so now then it changes course. Now changing course, so we have this one to be 200 kilometers, changes course to another point Z on a bearing of south, okay, south 60 degree east. Okay, so that means it's moving this way until X is directly to Z. Now we have Z here, all right? So now this has given me the idea of the question. So this is what I need to start with somewhere. So I already know the way the triangle is going to look like. So I can now go ahead and draw properly now. Okay, so now I'm starting with this. This is point X. Point X. So the aeroplane flies for north 45 degrees. So it is the angle made with the north. So north 45 degrees. Okay, to another point. That point is point Y. Can you see that? That's point Y. So we have point Y here. So the distance between X and Y has been given now to be 200 kilometers. So we have this to be 200 kilometers. Okay, now the aeroplane is here. It changes course and moves in another direction to point Z. So, and it moves on this bearing of south 60 degree east. This is east of Y and this is south. So it moves this direction. Okay, so this here, angle here is going to be 60. All right. So south 60. So this is done such that, okay, let's draw it this way. Okay, so this is 60 and this is point Z. Point Z is such that is directly at west of what? Of Z. Okay, so that means they are going to be on the same line. So this is point Z. So west of Z is point X. So that means we have a straight line here. All right, I hope you understand that now. So Now this is the movement, the trajectory of the aeroplane. It started from here, point X. It moves on the bearing of north 45 degrees east, then move for 200 kilometers. You now get to a point Y. It changes course and move on the direction of south 60 degrees east, and it moves down until it gets to a point where it's directly at where that point is, X is at west of Z. Okay, this X is at west of Z, directly at west of Z. Get that now? So this is west of Z. Okay, so, and that's the question. So now the question now says, calculate correct to three significant figures the distance X to Z. This distance, that's what we want to get now. So we can represent that with, let's represent that with small y. Okay, let's try and see if we can analyze the angle. Now the angle here is 45 degrees. And don't forget, this angle here is also alternate to this angle here. So that means this place is going to be 45 degrees. So I can simply tell you the total angle here is 105 degrees. Okay, so now can we get this last angle, because we want this now? So can we get this last angle here? So that is what now this angle here, this is 30, because this small angle here is 60. So 60 plus 30 is 90. So that means the angle here is 30. This is 30 degrees. Now you will see by the time you had all the angles together, it should give you 180. So when you add these three angles together, it gives you 180 degrees. So now, what formula are we using now? We're going to be making use of our sine rule. So now let's make use of our sine rule. Let's get that. We have sine y over side y equals to sine z over small z. Okay, so sine y, what is y? Y is 105 over small y equals to sine z, that's 30 over 200. So here you can cross multiply. We have y sine 30 equals to 200 sine. Now you can simply take this away from 180. We have 180 minus 105. Okay, so we have y equals to 200 sine 75. Okay, over sine 30. Okay, so now, and that gives you what? So can you compute this and tell me what the answer is going to be? Okay, so now sine 200 times sine 75 divided by sine 30. Okay, 200 times sine 75 divided by sine 30. So what are you going to have for that? So that's going to give us the distance here. So can you compute that? And let's have your answer in the comment section. Yes, anyone with the answer? Yes, anyone with the answer? Okay, I can see an answer. Okay, that's 386.37 kilometers. Okay, so now can we wait? Others, can you drop your answer? Make sure you are doing something. Okay. Okay, I can see Zakaria's answer. Okay. Okay, any other person? All right, okay, so we have that. So if you compute that, just like Sakaria and Okiki have done, you are going to have 386.37. So that's going to be in kilometers. But now let's look at the question. The question says correct to 3 significant figures. So that means I have to correct this to 3. I count 1, 2, 3. So I will truncate the remaining ones. So that means my final answer, the answer to this first one is 386 kilometers. Okay, so that's what we have for that. So that means this side now is 386.2337 kilometers. Okay, so that's the first part of the question. Now, can we look at the second part of the question? Let's see, what do we have for that? Okay, the question asks for the distance from Y to line XZ. This is line XZ. So what's the distance? Don't forget, this is a straight line, an horizontal line, okay? So now all we just need to do now, since we want to get the distance between these points and this, so let's draw a straight line down. Okay, that straight line is going to be perpendicular to the ground here. Okay, so that gives us a right angle triangle. Now let's call this R. So that means we have a right angle triangle XRY. So we want to get this side. Okay, so now let's look at this. We have this side, which is the hypotenuse. We have this side, which is the opposite, and this is the adjacent. So we want to get this side. Okay. All right. So how do we do that? So we use sine, or we use whichever one we want to use. So since we are connecting this and this, so we can use cos 45 equals to adjacent. Okay, adjacent, that is also adjacent is also opposite because our reference angle here is also 45. So adjacent, so that is my Ry over hypotenuse. So we have this. Okay, so you can cross multiply here. You have Ry equals to 200 cos 45. Okay, so then you can now do this. So what is cos 45? Please, can you tell me what is cos 45? Though it's a special angle that's square root of 3 over 2, but what's going to be the decimal form of that? So cos 45. So is there anybody with that? Cos 45. Cos 45. Anybody? Cos 45. Cos 45. Anyone? Okay, 0.7071. 0.7071. 0.7071. That's correct. Okay, so now let's multiply that by 200. So when you multiply that by 200, what do you have? Okay, 71. All right. So what do you have? You have 141.42. And that's going to be in kilometers. It's going to be in kilometers. Okay, so that's that. So we can correct our answer to 3 significant figures. So let's count 1, 2, 3. So our answer now is going to be 141 kilometers. Okay, so that is the answer to the problem. Any question, any observation based on what we just did here now? Any question, any observation? Okay. All right. Okay. So since there's no observation, so we are going to be stopping here for today. I want to believe you guys have learned one or two things. Don't forget, if you are new on this channel, you have not subscribed, ensure you do that, because this may be the last time you're going to be seeing me if you have not done that. And don't forget to tap the like button if you actually enjoy the class. All right. Okay. So don't forget, ensure you share this video with your friends. So we are going to meet in another time. Thank you very much. Bye bye.